Assalamualaikum. Hello and welcome to Gurukul Online Learning Network. Today I'm an instructor, Sheikh Mahadi. We're going to study Finance and Banking, Chapter 6, Long-Term Financing. So, in the previous class, we learned about the PVA, Present Value Annuity. Which one was the normal present value annuities? But this one is a bit different. It has including compounding. M gives off the result of compounding or the maturity principle. So, let's take an example. For an instance, some company wants to do their project by using a semi-annual bond of BDT taka 1000 par value with an 8% coupon rate. What does mean semi-annually? Semi-annually means 2 times in a year. That means after every 6 months, interest has to be paid. So the BDT 10,000 par value with an 8% interest of coupon rate. The principal amount will be repaid within 12 years. Find out the value of the bond whose return is 10%. So, PVA, our A, the amount of equal interest of annuity, which is A. Our A should be 80. 80 divided by our M. M showed semi-annual bond. Semi-annual bond, that means the compounding method, which would be 2 times in a year. So, 80 divided by 2. 1 minus 1 plus I. Interest rate, our interest rate given was 10%, that means 0.10. 0.10 divided by the M, which is the compounding. It will be 2. N into M, our given time, our given total time in which the amount has to be repaid was 12 years. 12 years indicates N. Number of years indicates 12 and M is equal to 2, which was the semi-annual payment period. I is equal to 0.10 divided by M. M is the semi-annual compounding. 2. Let's close the bracket. M is 2. 1 plus I would be 0.10. M is 2. Sorry. To the power N. N would be 12. So, as for basics, this M, the uppercase M indicates the principal payment at maturity, which was the BDT 1000 par value, and the smaller case. And the smaller cases always indicates the compounding time. Compounding methods are compounding time. So, this M would be 1000. So, if we just break it down and come up to a final conclusion, just do the maths at your home, at your own process. It could be done so easily. That will be 862.10, the present value. So, find out the value of bond when the required return is 10%. The required return would be 10%. That will be BDT taka 862 taka. The symbol won't be necessary. Anyway, so yield to maturity. Let's take a discussion about that. We have 2 kinds of math, yield to maturity and YTC, yield to call. So, first, yield to maturity, YTM. What is that? YTM is the rate of return that an investor would earn if he bought the bond at its current market price and held it until maturity. What does it mean? Current market price. When the market price, suppose the market price of the bond was going at taka 200, at that time he bought it and held it until the bond was being matured. At the end of the time, or the payment of the bond has to be given out. That means the until maturity. Basically, it represents the discount rate at which it equates with the discounted value of the bond with the bond's future cash flow to its current market price. That means bond's future cash flow. The cash flow that will be given within the bond to its current market price. These two are discounted within these 2 formalities or these 2 entities. So, the rate could be determined by trial error method to equate the future cash flow to present market value. Could be determined by trial error method. This is known as a trial error method of YTM, yield to maturities. Cash flow, as the process a bit lengthier, it will be another way to find out the approximate YTM. It is the trial error method. So, in this case, we know I is equal to, I will always be the interest rate, M. M would be the face value or the maturity of the bond. SV, as we all know, sales value, and A is equal to n is equal to simply the number of period or the time or the years, as we said. So for an example, company X has issued a 10-year bond with a face value of BDT 10,000, BDT 1,000. 10-year bond, 10, that means 10 goes to N, 1,000 bond, 1,000 goes to M, 1,000 goes to M, and the coupon rate is 10%. Why do we put the coupon rate of the 10%? Then we'll figure it out later. But if the market value of the bond is taka 1,800, what would be the value of the YTM if the bond is hold until maturity? Bond is hold until maturity. So let's put those all down in a formula. So annual interest, I is equal to shows annual interest will take of 100. Annual interest of taka 100 plus the maturity would be 1,000. As we mentioned, the SV sales value of that or the market value of that bond is 1,080 divided by N. N was given in terms of period or in number of years, was 10. So M plus SV, M would be the same, 1,000 plus 1,080 divided by 2. So this is just the simple math equation or the formula. We break it down. If we break it down, we'll get a simple of this section gives us of 92. Calculate that, and the rest one 1,000 plus 1,080 divided by 2 will get us a total summation of 1,040. Divide that, you will get 8.84%, or in some cases 0.08884. We'll just directly convert it into a percentage form. Sorry, 8.84% is the YTM or the yield. That was the yield to maturity. So let's take a look at YTC, yield to called. Here C will be mentioned as call price. So it's mentioned earlier that many bonds may have a provision and can be called upon. In that case, a bond holder may not be eligible to hold any kinds of until its maturity. So the YTM in case will become useless. The YTM that we just did over here, YTM, in that case, if that's the case, that the bondholders may not be able to hold the bond until its maturity, in that case the YTM will be entirely useless. That process or the method of mathematician won't be used. So rather YTC or yield to call, it comes into determination. So YTC is the rate of return that an investor would earn if he bought a callable bond at its current market price and held it by the call date. Call date and callable, call date and maturity, those two are mostly different, but basically it represents the discount rate at which it equates the discounted value of the bond's cash flow and its current market price given to the bond. That is mainly called call date. Like YTM, YTC could be determined the trial error method that we just did. The YTM, it was called the trial error method to equate the future cash flow to present the market value. But approximately YTC can be calculated by using the previous formula, which is same, almost same as the YTM, which is 1 plus C minus MV divided by N, C divided by C plus MV by 2. C is called the call price over here. C is known as the call price. So we'll take all of these requirements as same as there. So I is equal to, we'll take, let's take the math over here. We will take I is equal to 100. Plus our C was the call price. How much was the call price? 100 and 1060. 1060 given call price, 1060 minus MV. MV is the market value of the bond, which is 1100. We can find out these numbers in our textbook through some different kinds of examples. N, our given number of years was only 4, the N. So in the next stage, 1060 minus 1100 divided by 2, just as same as the YTM and YTC. Those two are interrelated or same as each other, just the difference would be in the C. $110 goes for this upper section, and for the lower section we'll get 1080. 1080. Without saying, we can get a 10.19 percentage. 10 divided by 10. 10.19 is considered as the YTC of that. Same kinds of math, you can find it in your textbooks. So, like this, we just finished the chapter 6's YTM and the YTC methods within the present value annuities. In the future, we maybe learn about the future value annuities and the other bond interest rates. So, as far as this, if you have any kinds of question regarding this class, please let us know down in the comment box below, and be with Gurukul. Thank you so much.